Welcome back to the deep dive. Today we are opening up a topic that, well, on paper it might seem a bit dry,
Just
a certification exam blueprint, but we're going to try and find out why it's actually something more, almost like the physics textbook for the modern private cloud. We are tackling the VMware Cloud Foundation Specialist exam, specifically the 2V0-17.25.
it's great to be back. And I love that framing because when you look at the source material we have today, which is this stack of pretty rigorous practice scenarios and technical explanations, it's not really just about memorizing answers to pass a test.
Right.
It's about getting the logic of how a massive software-defined data center is actually, put together.
Exactly. We've got 10 specific scenarios from the exam prep material in front of us, but our mission really isn't to give you a cheat sheet. It's to look at the architecture, the planning, and the operations of VCF VMware Cloud Foundation. For anyone who's not deep in this is basically the full stack solution, right?
That's it. Compute, storage, networking, all wrapped up in a single management layer. It's the standardization of the data center. So if you want to understand automation at an enterprise scale, this is the playbook. The exam covers, 4 big areas: architecture, fundamentals, planning, and operations.
But what does it all boil down to?
Honestly, it all boils down to one thing. How do you take a room full of servers and turn them into a single intelligent organism?
An intelligent organism. I like that. So let's dissect it. The first thing that jumps out from the source material, specifically question 1 in our stack, is how VCF organizes its internal organs. It asks about the types of domains in a standard deployment.
This is the foundational concept. I mean, if you get this wrong, you don't have VCF. You just have a mess.
The question lists a bunch of distractors: storage domains, compute domains, separate network domains. But the answer, the only supported answer for a standard architecture, is 2 specific kingdoms: the management domain and the workload domain.
Right, and the distinction here is absolute. Think of it in terms of like church and state. The management domain is the church. It's where the high priests live, the vCenter server, the NSX managers, and the SDDC manager, which is the brain of the whole operation.
And that's mandatory.
It's mandatory. It's the very first thing you build.
And the workload domain.
That's the state. That's the populace. That's where your actual applications, your SQL servers, your web apps, your tenant workloads, that's where they actually live.
Why the strict separation? Why can't I just throw my management tools onto the same cluster as my heavy database?
You can, but in a standard architecture, you absolutely don't want to. It's about the noisy neighbor problem, for one, but it's also about lifecycle management.
Go on.
Imagine you need to upgrade the infrastructure that runs the cloud, the vCenter, the monitoring tools. If those are mixed in with your customer-facing apps, an upgrade glitch could take down the entire business.
Right. You don't want to shut down the factory floor just to paint the manager's office.
Exactly. By separating them, the management domain ensures the brain always has dedicated resources. It can think, plan, and orchestrate, regardless of how hammered the workload domain is by user traffic.
And you can scale them independently.
That's the other key. You can add more dining rooms for customers without rebuilding the kitchen.
That makes perfect sense. But the exam throws a curveball in question 2. It introduces a scenario where maybe you don't have the luxury of endless racks of servers. Maybe it's a smaller environment or, a proof of concept lab.
Ah, yes. The consolidated architecture.
The question asks how the domains are organized when you have a small hardware footprint. And the answer is that the management and workload domains run on the same physical cluster.
This is the reality check. In a perfect world, sure, we physically isolate everything. In the real world, sometimes you only have 4 or 6 hosts. So consolidated architecture allows the management workloads and the tenant workloads to share the same metal.
But wait, doesn't that violate the golden rule we just talked about? The whole separation of church and state?
Physically, yes, it does. But logically, no. And that's the key takeaway from the source material.
Okay, how so?
Even in a consolidated design, VCF uses resource pools to prioritize the management components. It draws a logical line in the sand. It basically says, okay, you're sharing the CPU, but if push comes to shove, the management components get to eat first.
So it maintains the structure of VCF even if it compromises on the physical isolation to save money or space.
Exactly. It reduces the hardware bill, but you are trading off that hard failure isolation. It's a supported design, but usually for specific use cases, like remote offices or labs.
Not where you'd run a Fortune 500 company's production environment.
Never done if you could avoid it, but for a smaller branch office, it's perfect.
Okay, so we've got our domains, we know where things live. Now let's talk about how they get there. There's a fascinating tension in the exam questions, specifically 6, 7, and 8, about the tools involved. It feels like a relay race.
It is a relay race.
Yeah.
And dropping the baton is not an option.
Let's start with question 6. It asks about the bring-up process. Who actually builds the initial house? The options included things like vCenter or NSX Manager, but
But those are the things being built.
exactly. The correct answer was Cloud Builder.
Cloud Builder is a fascinating piece of software
Yeah.
because its entire purpose is to exist for maybe 4 hours, do a ton of heavy lifting, and then just retire.
It's the construction crew.
Perfect analogy. You have a stack of bare metal servers, total blank slates. You can't use vCenter to configure them because vCenter doesn't exist yet.
Right.
So you download the Cloud Builder appliance, you feed it a very specific spreadsheet, the deployment parameter workbook, and you tell it go.
And what does it actually do?
It validates everything first.
Yeah.
It checks if the networks are reachable, if the passwords meet complexity requirements. Then it installs ESXi on the hosts. It deploys the first vCenter. It configures the first NSX manager. And then finally, it deploys the SDDC manager.
It bootstraps the entire universe.
It does.
Mhm.
But here is the critical distinction that question 6 is getting at. Once that bring-up is done, Cloud Builder is finished. The source material is explicit. After bring-up, Cloud Builder is no longer used for ongoing operations.
Which leads us directly to question 7. The house is built. The construction crew has left. Now, who takes out the trash? Who fixes the leaks? The question asks about patching, upgrading, and password rotation.
And the answer there is the SDDC manager. If Cloud Builder is the construction crew, SDDC manager is the property manager. It lives in the management domain permanently.
And this seems to be where the automation value prop really kicks in. The source material mentions that SDDC Manager handles password rotation for infrastructure components.
Which sounds incredibly boring until you've had to do it manually.
Oh, I can only imagine.
Think about it. You have vCenter, NSX, maybe some other tools, dozens of different service accounts. If you change a password on one system but forget to update the script that connects it to another, things just break. Alerts stop firing.
Yeah.
Backups fail. SDDC Manager automates that rotation across the entire stack. It ensures the new keys are distributed everywhere they need to be.
That touches on question 4 as well, regarding SSL certificates.
The bane of every admin's existence.
The question asks which component centralizes certificate management. And again, it's SDDC Manager.
And the insight here is all about reliability. Manual certificate management is a ticking time bomb. I mean, everyone has a story about a service going down because a cert expired on a Sunday night.
Yeah.
SDDC Manager treats certificates as a lifecycle object. It generates the request, gets it signed, and installs it. It removes the human error element entirely.
So Cloud Builder gets you to the starting line, and SDDC Manager runs the marathon.
That's the split, and it's crucial for the exam. If the question is about deploying the initial management domain, it's Cloud Builder. If it's about anything that happens on day 2 patching, certs, expanding clusters, it's SDDC Manager.
Speaking of day 2 operations, question 8 asks about a coordinated upgrade of vSphere and NSX. This isn't just hitting update on an iPhone.
No, not at all. This is the dependency hell that VCF is designed to solve. You generally can't upgrade ESX, the hypervisor, until vCenter is upgraded. You might not be able to upgrade vCenter until NSX is at a certain version. Or maybe it's the other way around, depending on the specific release notes.
And figuring that out manually requires a lot of reading and coffee.
It requires a PhD in release notes. SDDC Manager contains the logic. It knows the interoperability matrix. It essentially says, nope, I won't let you upgrade the host yet because the vCenter isn't ready. It orchestrates the whole sequence so you don't break compatibility. It takes the anxiety out of Patch Tuesday.
That's a massive safety net. But, and this is a big but, automation is only as good as the foundation it sits on.
Garbage in, garbage out. Absolutely.
Which brings us to what I'm calling the invisible foundations. Questions 5 and 10 in our stack deal with external infrastructure services. These are things that VCF doesn't build itself. It expects them to be there, and they better be perfect.
These are the questions that trip people up because they assume, oh, I'll just fix that later. In VCF, there is no fixing it later.
Question 10 asks about a mandatory service that requires both forward and reverse lookups.
DNS, the domain name system.
It seems so basic. Why is the exam so specific about reverse lookups?
Because VCF is paranoid. And it should be. When you tell Cloud Builder, hey, go install ESXi on IP address 192.168.1.90, the system doesn't just trust you. It does a reverse lookup on that IP to see if it resolves to the host name you claimed it was.
It's verifying identity.
Correct. It's also critical for all the components to talk to each other securely. If the forward and reverse records don't match, or if they're missing, the installation scripts will just time out and fail. You won't even get past the validation phase.
So you can't build a cloud if your phone book is messy.
Not a chance. And the other critical piece, highlighted in question 5, is NTP.
Network time protocol. Why is time so critical? The question mentions authentication.
Well, think about how modern security works. Things like Kerberos tickets or secure tokens, they often have a very short lifespan. If your vCenter thinks it's 2.0 day PM and your ESXi host thinks it's 2.05 PM,
The authentication token is basically expired before it even arrives.
the door is locked because your watch is wrong. Exactly. And then there's logging. If you have a crash and you're trying to correlate logs across 10 servers to find the root cause, but the timestamps are all drifting by a few seconds, it is mathematically impossible to reconstruct the timeline. You'll never know what happened first.
So the takeaway here for you listening, before you even download the VCF bits, your DNS and NTP need to be rock solid.
They are the invisible rails the train runs on. If the rails are bent, the train derails immediately.
Let's shift gears to storage. We've built the management, we've standardized the time and names. Now, where do we put the data? Question 3 asks about principal storage options for a workload domain.
This is another area where VCF is very prescriptive. The question asks what is supported for the main data stores that the automation manages.
The options included things like object storage, tape libraries, generic NFS, but the correct answer pair was VSN and fiber channel.
And this tells you a lot about the design philosophy. VSN is the native choice. It's software-defined storage running on the servers themselves. It's fully integrated. SDDC Manager has complete control over VSN. It can configure it, patch it, expand it, all automatically.
And fiber channel.
That's the concession to enterprise reality. Many big companies have spent millions on massive external storage arrays, from Pure, Dell EMC, NetApp connected via fiber channel. So VCF supports using those as principal storage.
But interestingly, NFS wasn't the correct answer for principal storage, at least in the context of this specific question.
It's a nuance. VCF can use NFS for supplemental storage, and newer versions are expanding support. But for the principal storage that acts as the bedrock for the domain deployment in this exam's context, the preferred highly automated paths are VSN and fiber channel.
So the exam wants you to know the happy path.
The path of least resistance for the automation. It's about reducing variables again. If you use vSAN, VCF knows exactly how it works. If you use some random NAS box, there are too many variables to automate reliably.
Standardization breeds reliability.
Exactly. When you limit the menu options, the kitchen runs faster.
Now, we've talked about the management domain being the first thing you build, but usually you buy VCF because you want to run workloads. Question 9 walks us through creating a new workload domain.
This is the moment where you expand the empire.
The question asks, when you click that button to create a new workload domain, what gets deployed automatically?
And the answer is vital. A dedicated vCenter server and a dedicated NSX manager instance.
Wait, so we don't just use the vCenter we already have in the management domain?
No, absolutely not. And this goes back to our church and state discussion, but it also introduces the concept of failure domains.
Break that down for me.
If you had one massive vCenter managing, say, 5,000 hosts, and that vCenter corrupted its database, you lose management for everything. By giving each workload domain its own vCenter, you compartmentalize the risk. If the vCenter for the HR app domain goes down, the finance app domain is completely unaffected.
It's like watertight compartments on a ship.
That's it. Plus, it allows for different lifecycle policies. Maybe your legacy app domain needs to stay on an older version of vSphere for compatibility reasons, while your AI dev domain needs the bleeding edge.
Because they have separate vCenters, you can upgrade one without touching the other. That is a huge operational advantage.
It creates flexibility through isolation. And again, notice the automation. You don't have to manually install a Windows VM, mount an ISO, and click through an installer. SDDC Manager just spins up the appliance, configures the IP, and connects it to the SSO domain automatically.
Thank you for helping us decode the blueprint today.
Always a pleasure to look under the hood.
And to our listener, thanks for sticking with us. Next time you're looking at a cloud architecture diagram, I hope you don't just see boxes and lines. I hope you see the invisible logic, the failure domains, and the rigorous standards that keep the lights on. Thanks for taking this deep dive with us.